Good morning, dear students. Today I'm going to take a class for BSc 5th semester students. So today I'm going to derive radial acceleration and transverse acceleration. In the last class we have derived the equations for radial velocity and transverse velocity. Okay, so now today we derive radial acceleration and transverse acceleration. So as in the last class we have derived r1 bar as cos theta I plus sin theta j. Okay, so this we have derived in the last class. Now call this equation as 1. Now differentiating this one with respect to t. Okay, so here to derive radial acceleration and transverse acceleration we need two extra quantities. So those are dr1 by dt and d theta 1 bar by dt. Okay, so first we obtain those quantities. Okay, so now to get those quantities, now we have r1 bar is equal to cos theta I plus sin theta j. Okay, so now differentiating this equation 1 with respect to t. Now see here, this function is both function of both r and theta. r1 bar is function of both r and theta. So therefore what we do, we apply total derivative formula. So which you have studied in your second year BSc second sem. Okay, so to differentiate that one, so what we do is, so dr1 bar by dt is equal to so here first we differentiate r1 bar with respect to r. So dou r1 bar by dou r, then dr by dt, then plus next r bar is also function of theta, so therefore dou r1 bar by dou theta into d theta by dt. Okay, so this is a total derivative. So why we use total derivative? Because when a function is more than a function of more than one variable, so then we use the total derivative formula. So here dr1 bar by dt is equal to dou r1 bar by dou r, then dr by dt plus dou r1 bar by dou theta, then d theta by dt. Okay, so now in this case, now see here, we find dou r1 bar by dou r, okay. So now see here, this is r1, now there is no r term, okay. So therefore when you differentiate this r1 bar with respect to r, then it becomes 0. Okay, so therefore, so dou r1 bar by dou r, here this is equal to 0. So here we have taken this is equal to 0 into dr by dt as it is, then plus. Now in this case dou r1 bar by dou theta. Okay, so now what we do is we differentiate this r1 bar with respect to theta. So dou r1 bar by dou theta is, that is minus sin theta I plus, then this is cos theta j. Okay, simple. So therefore dou r1 bar by dou theta is minus sin theta I plus cos theta j, this d theta by dt as it is, so this is dr1 bar by dt. Okay, now so therefore on simplification, so this becomes 0. Okay, this complete term becomes 0, and only we have the second term only, second term, so that is equal to, so here dr1 bar by dt can also be denoted as r1 bar dot. So this is r1 bar dot. So dr1 bar by dt is the same as r1 bar dot. So already dot means what? It's a differentiation with respect to t. Okay, so therefore r1 bar dot is equal to, now see here again this first term becomes 0, and this minus sin theta I plus cos theta j, already in the last class we have derived this one. So this is nothing but theta 1 bar, okay, this is theta 1 bar, and into, so d theta by dt, so this d theta by dt is nothing but what? Theta dot. Okay, So d theta by dt means what? It is theta dot. Theta dot means it is differentiation with respect to t. So therefore this whole term takes the form of this one. So which is the equation 2, which is equation 2. So r1 bar dot is equal to theta 1 bar into theta dot. Okay. So now we got one quantity, that is r1 bar dot. Next we find another quantity. Okay, so now again in the last class we have derived this equation. Okay, so theta 1 bar is equal to minus sin theta I plus cos theta j. So call this equation as 3. Again what we do, we again differentiating this equation 3 with respect to t, as we did in this case. Okay, in the same way we derive, we differentiate. So here d theta 1 bar by dt is equal to, so first differentiate theta with respect to r, that is dou theta 1 bar by dou r, then r with respect to t, that is dr by dt, then plus, then again dou theta 1 bar with respect to theta, so dou theta 1 bar by dou theta, then again theta with respect to t, that is d theta by dt. Okay, so then next is, now first we find dou theta 1 bar by dou r. Now again theta 1, it does not contain r, so again this first term becomes 0. So dou theta 1 bar by dou r is 0, so this complete term is 0. Next here theta 1 is a function of theta, so dou theta 1 bar by dou theta, when you differentiate this with respect to theta, which gives minus cos theta I, then minus sin theta j. Okay, so that is minus sin theta I plus cos theta j, taking minus common. So sin theta I plus cos theta j, so this we have already proved in the last class, which is nothing but r1 bar, into this d theta by dt is nothing but theta dot, into this is theta dot, then we have taken already minus common, then this first term becomes 0, this term, whole term becomes 0, only we left only with this term, so that becomes theta 1 bar dot is equal to minus theta dot into r1 bar. So theta 1 bar dot means what? It is again